So the last time we talked, we were working on probability distribution tables. And again, I didn't record this, but you can, the YouTube video that I just uploaded, if you want to review it, you can. Let's talk about something called, so the part 2 of this chapter, which is the binomial distribution. And as you can probably tell from the word binomial, it means 2 outcomes are possible, only 2. Right? With the probability distribution from yesterday, the number of events, right, from 5.1, you know it's going to be a problem from 5.1 if the number of events is more than 2. Right, the probability of 0, 1, 2, 3, 4 defects in the microchip or whatever it was. But with binomial, it's just 2. There's 2 outcomes possible. But this gives us a larger or a more powerful analysis tool, as you'll see here. And the best way to categorize this are examples like pass and fail, accurate, not accurate, right and wrong. And there's a classic example, and they talk about this in the textbook at the end of this section, and it's a good one, is let's say that you're writing your quiz number 3. And there are 8 questions on the quiz that are multiple choice. There are 4 correct answers. Sorry, there's 4 possible choices, right? A, B, C, D. And 1 correct answer. What is the probability? So this will be the first question that you would see. What is the probability of guessing? So let's say you don't study. Maybe this is what you're thinking in the back of your head. Maybe I won't study. What is the probability of passing the quiz if you guess every answer? All right. So enter the binomial equations right here. So this is the master equation right here. And we're going to learn how to use these as well today. Binomial, binomial. And as we'll see, one of the advantages of the binomial is that calculating the mean and the standard deviation is a lot simpler than, well, I guess it's not simpler, but it's just as simple as in the first situation with a probability table. The Poisson distribution, this is the one we'll handle on Friday. Which is actually my favorite one. We'll talk about that later. But for now, you're going to know that this is a binomial problem for a few reasons. One, it's discrete, right? It's, 8 questions, 4 possible choices. And what should come to your mind here is that if you have 8 questions on the test and you need to get 4, there's 4 choices, 1 correct answer. On any given question, what is the probability of getting it right? Right? If you let's say there's just 1 question, the probability of a correct answer, and we're going to call that P. The probability, this is going to be in the equation, the probability of success, or your desired outcome. Well, the probability of success, if it's 1 in 4, is going to be 1 in 4, or 0.25. And that's on any given question. So let's say you wanted to figure out what's the probability of getting them all right. Right? What's the probability of getting 100%? Well, that means that you'd have to, on every single question, there's 8 questions. It's going to be, you have to get them all correct, and so on. It would be just, the probability of getting 100% is 0.25 to the power of 8. Right? You're going to need to guess 1 quarter, 1 quarter, 1 quarter, 1 quarter. But to just pass this is where you have to enter the binomial equation, because if you're saying that I only need to get, to pass the quiz, you just need 4 out of 8. Right? The probability of 4 out of 8 is more confusing because it's a combination issue. You could get these first 4 right, or you could get, this one right, this one right, this one, and this one. Or, the order doesn't matter, but you have to get 8 out of 4. Sorry, 4 out of 8. And so that's where the binomial equation comes into play. You'll see that you're going to multiply, at the beginning here, you figure out how many you need to get out of the total possible. So that's why it's a combination to lead it off. That's why it leads off with a combination. So let's say the question was, what is the probability of getting 4? Well, the probability of getting 4 correct. So the binomial equation says, well, you're going to have there's 8 possible, choose 4. The probability of getting something right is 25. That's the p-value. And I would need to get 4 of those. And then you'll notice there's a q value in the equation. Let me just write down the equation here. The probability, so q is the probability of not a success. So q is always 1 minus p. This is the complement event, as we say in statistics. So the probability of getting exactly 4 wrong and exactly 4 right would be this. Because again, there's multiple ways to get 4 out of 8. And this is telling us that this is going to be exactly, you're going to get exactly 4 right and exactly 4 wrong. And you can do this in your calculator. And in the old days, you would have to, right? Again, this is one of the advantages of COVID and distance learning and open book, is that you can use Excel for everything. But in the old days, you'd have to use your calculator, and you'd have to go, 8, choose 4, and you can do this like that. In fact, it's good to use the calculator to verify, to make sure you're doing it correct in Excel. And you would see you have approximately a 8.7% chance. But that's getting exactly 4 correct. Like that's if you're placing a bet with your buddy and you said, I'll bet I can get exactly 50% on this test. But this is where this becomes more interesting. To actually pass, you could also get 5, 6, 7, or 8 correct. Right? The probability of passing is not just to get the chances of getting 4. The probability of passing is the probability of 4 plus the probability of 5 plus the probability of 6 and so on. And that's where Excel is going to come to our rescue. Is that to pass, to actually answer this question, to pass, really you need to figure out what is the probability that x is greater or equal to 4. And again, you could think of it as probability of 4 plus 5. And the chances of this get smaller and smaller, obviously. But the problem that in calculating this is you have to do 5 calculations because there's 5 ways to pass it, like 5 different scores that pass. And you could go into your calculator and change this to 5, change this to 5, change this to 3, and so on. Right? If you wanted to do the probability of, let's say, 5, the only things that would change there would be 8, choose 5. That's what you would change in your calculator. But let's use Excel because otherwise you have to keep, it takes a long time. And so Excel has an amazing function. So if you want to figure out the problem, let's say you want to do the probability of 4 in Excel. Here's what you would input. You would go equal binomial distribution. And then you're going to put in, it's a little confusing. That's why you need practice, as we'll see. You don't do 8, choose 4. They want 4 first, and then they want 8, and then they want the p-value. And then you're going to input 0. I'll explain that in a second. So let's actually just make sure I get the same number as this. Right? Let's make sure that this, because this should give me, that should give me this, the way I've entered it. Yeah, let's just keep working on this spreadsheet. All right, so if I want the probability of 4, let's go to another. If I want the probability of 4, I would say equals binomial. You'll see binomial distribution right here. And I'm going to say, so it says number S, that means successes, right? So I want 4, and then trials is 8. The probability of success, that little s, 0.25. And the next command, it says cumulative. And you'll see this a lot in Excel, especially going forward, something called a true or false selection. So 0 is false, 1 is true. And I want false because I don't want a cumulative result. And I'll show you when we do want cumulative in a minute. But we're going to want not cumulative. We don't want everything up to and including 4. We just want 0. Sorry, we just want 4. So we put in a 0. And that's the command that'll give us the same answer, as you'll notice, as my calculator. 0.8 652. Right, so I got the same answer there. So what's the probability of 5 correct? Well, if you want to see the chance of guessing 5 out of 8 correct, you would just do the exact same thing. Let's just copy that down here. Oops. Let's not do that actually. Right. And then I can change this to a 5. That's all you got to do. Just got to change that to 5 and you're in business. And as you can see, the probability of getting that is less because, as you can imagine, it's harder to guess 5. It's harder to guess 5 than 4. And you could keep doing that all the way. You could do 6, 7, and 8. But again, there's an easier way, and especially when we start dealing with larger number sets that we will very soon. Let's say you have something like 20, like that coin toss question in the lab that I gave you. You don't want to keep going. You want to figure out an easier way, and there is an easier way by using that cumulative function that I'll show you right now. So now, so here's the logic that I'll be using, and hopefully this makes sense to everybody. If the probability of a pass is greater or equal to 4, you can also think of this as 1 minus the probability that x is less than or equal to 3. Right, which is the same thing, right? Less than and equal to 3 is the probability of 0, 1, 2, or 3. Right, this is probability 0, 1, 2, and 3. And here we can use the cumulative function. You can do this again. You can add this up. You can go 1 minus these 4 probabilities, or we can use Excel's, the power of Excel to enter 1 minus the binomial distribution of 3, 8, 0.25, and then we put 1. And that 1 signifies that I want you to add up everything up to and including 3. So this will give us this sum here. This is this. So the probability that x is greater or equal to 4 would be 1 minus the binomial 3, 8, 0.25, and 1. So in other words, you have an 11% chance of passing. In other words, you have an 11% chance of getting 4 or more correct. There's a 9% chance that you'll get exactly 4. There's a 2% chance that you'll get exactly 5, but you can imagine 6, 7, and 8 decrease exponentially. And that's how you use the binomial probability to calculate things like that. Let me give you another example. Just while we're at it here. One more example. Let's say the probability of a COVID test of a positive COVID test, just because it's my favorite subject, as I'm sure it's your favorite subject these days, is 0. Let's say the variant increases, and let's say there's an 11% or 12%. Let's say there's a 12% chance of a positive COVID test with the new variant. Right now it's about 4% or something, right? Let's say it goes up to 12. What is the probability? So let's say we know that. What is the probability that 3 out of 12 students, or let's say 10 students, let's make it 10. 3 out of 10 students test positive? So this one's pretty basic, right? All you would have to do is you'd say, okay, so probability of 3 out of 10 would be 10 choose 3. And then I would need 0.12, right? That's the probability of a positive test. The probability of a negative test would be 8. And I would need 7 students to test negative. So again, you could do this with your calculator, or you could use Excel. Either way, you should write it down like this when you're showing your work, just so it, you know, show me that you know how the equation works. So again, you could do it here. So again, 8.5% chance approximately. So that's fine. You can just use your calculator for that. Or again, you could use in Excel binomial distribution. 3, just make sure you remember it's the opposite. 3, 10, 0.12, and 0, because I just want exactly 3. But again, a more realistic situation would be, what is the probability that at least one person, right? Because that's the real question you'd want to be asking yourself, is what is the probability that out of 10 students, more than one, or let's say more than 2, because it'll be more interesting with Excel. Let's say more than 2 test positive. So how would I solve this? You would say, again, write down a formula that makes sense, right? So, use the notation. So this is the probability. So more than 2. That means x is greater than 3, or greater than 2, right? More than 2 is greater than 2. Is going to be 1 minus the probability that x is less than or equal to 2. more than 2 is the same thing as 3 or more, right? Again, that's where it kind of gets confusing, right? This expression here is the same thing, right? This is the same thing as x is greater or equal to 3 in a discrete situation, right? If it's more than 2, that means it's 3 or more. And the more the more questions you do, the better you are at deciphering these things. But again, when you're first learning this stuff, it's confusing. So more than 2 would be 1 minus the probability that x is less than 2, or less than or equal to 2. And this is a lot, again, quicker to use in Excel, because here you would have to do 0, 1, and 2 by hand, or you could just do binomial to 10 and 1, because I want cumulative there. %11 chance. 10.87%, or 0.1087.